In this lesson, we are working on systems of linear inequalities. We will be graphing and then explaining the solution after we graph. Remember, for linear inequalities, what we want to do is we want to be sure that each of the inequalities is written in the form of y equals mx plus b, where m is the slope and b is the y-intercept, in order to graph. Then, when we graph, we want to make sure that we remember that a greater than or equal to or a less than or equal to is our solid line. A greater than or a less than is the dashed line. Then we want to shade on one side of the line or the other by picking a test point to see where we should shade. Again, be sure to get the y by itself before you graph. Let's take a look at our first system. Systems of linear inequalities. Our first system, we have y is less than or equal to 2x plus 3 and y is greater than x minus 1. So with our first inequality, y is less than or equal to 2x plus 3, our y-intercept is at 0, 3, and our slope is at 2. So we'll put our first point on the coordinate plane at 0, 3, and find a couple of other points by using the slope. Up 2 over 1. Up 2 over 1. Our symbol is less than or equal to, so that's going to be a solid line. We're going to label that as y is less than or equal to 2x plus 3. And we're going to test a point to decide where to shade this one. So I'm going to test the point 0, 0. And I'm going to plug that in. Is 0 less than or equal to 2 times 0 plus 3? Is 0 less than or equal to 3? Yes, it is. So we're going to shade on this side of the line where the 0, 0 is located. Next, we're going to graph the other inequality. Y is greater than or equal to x minus 1. My y-intercept is at the point 0, negative 1, and my slope is at positive 1. So I'm going to graph that point and change color so it's easier to see at 0, negative 1, and then I'll use the slope up 1 over 1, up 1 over 1 to find other points. I look and it's greater than or equal to. That means I need a solid line, so I'll graph that. I'm going to label this line as y is greater than or equal to x minus 1. And now I'm going to pick a test point. And this line also does not pass through the origin 0, 0, so I'm going to test that. Is 0 greater than or equal to 0 minus 1? Is 0 greater than or equal to negative 1? Yes. So that means I'm going to shade on this side of my line. And what happens is that this section right here, this triangular shape, is the part where the shading overlapped, which means that is the intersection, and that is where the solution to our system of inequalities is. And so I'm going to shade this heavier with a highlighter for you to see, but in your notes all you have to do is make that section much heavier and darker to show that is the point where, or the section where all of those points would be solutions to our system of inequalities, where the shading overlaps. Here's our next example. Negative 2y is less than 4x. Remember, we want to get the y by itself, so we're going to divide both sides by negative 2. So we have y, make sure you flip the inequality symbol, is greater than negative 2x. Our y-intercept is at the origin, which is 0, 0, and our slope is at -2. So we'll put our point at the origin and we'll use the slope -2 down 2 and over 1 to find other points to graph. And we also need to look at our symbol and we see that it is a greater than, or in the original a less than, so we need to have a dotted line or dashed line. I'm going to label this, and I'm going to label it with my solved version, so y is greater than -2x. And in this case, I need to decide where to shade. I can't use the origin because my line passes directly through the origin. But I'll use something simple like the point 1, 1. So I'm going to test the point 1, 1 to see if I need to shade up to the right of the line or below down to the left. So I'm going to plug that point in. Is 1 greater than -2 times 1? Using my solved version. 1 greater than -2. Yes, 1 is greater than -2. So I'm going to shade where the point 1, 1 is located. In my second inequality, 2x plus 3y is less than or equal to 6. I am going to subtract 2x from both sides. To get the y by itself, so I have 3y is less than or equal to -2x plus 6. Then I'm going to divide all of the terms by 3. So I have y is less than or equal to -2/3 x, but simplifying 6 over 3 to 2. Therefore, my y-intercept is at 0, 2, and my slope is at -2/3. So I'm going to graph at 0, +2, and then I'm going to use my -2/3 down 2 and over 3 to find a couple of other points. I look at my inequality symbol and it's less than or equal to. I need a solid line. I'm going to write my inequality beside my line, so I have y is less than or equal to -2/3 x plus 2. In this case, I need to decide if I should shade down below to the left of my red line or up above, and I can use the point 0, 0 now as my test to see if that's where I should shade. Plugging it into my solved version right here is 0 less than or equal to -2/3 times 0 plus 2. Is 0 less than or equal to 2? Yes, it is. So that means I shade where the origin is, which is on this side of the line. And you'll notice in this triangular area right here, my shading overlaps. So I'm going to take my highlighter. You can use your pencil and just make it darker. This is the solution to my system of inequalities. In this region are the points that would be solutions to both inequalities. Here is my next system of inequalities. Y is greater than or equal to 3. Remember, when y is greater than or equal to 3, that is a horizontal line at the y value of 3. So I'm going to count up 3 on the y-axis, and I'm going to draw a horizontal line, and according to my symbol, it needs to be solid. I now want values that are greater than or equal to 3. That means that those values would be above the line. Next, I have x less than -5. That is going to be a vertical line at x being negative 5. So I'll put my point at x being negative 5, and I need to draw in a vertical line at x being negative 5, and looking at my symbol, it's less than, so that will be a dashed line. Now to shade the region, it says x is less than negative 5, so all of my values that are to the left are going to be less than negative 5. In this case, these two areas now overlap, and that section, which is this rectangular section, would be the solution to this system of inequalities. All the points in that area would be solutions to the system. Let's solve this system. In our first inequality, y is greater than negative 1/2 x plus 5. My y-intercept is at 0, 5, and my slope is at negative 1/2. So I'm at 0, 5 for my first point. Then I'm going to use my slope down 1 and over 2 to find some other points to draw my line. When I look at my symbol is greater than. That means I need a dashed line. I'm going to label this as y is greater than negative 1/2 x plus 5, and I'm able to use the origin as my test to see if I should shade below to the left in this region or up above. I'm going to test 0, 0, the origin, and when I plug it in, 0 greater than negative 1/2 times 0 plus 5. Is 0 greater than 5? No. That means I'm not going to shade where the origin is, since I said no, but that the points above to the right of the line would be the points that would be the solutions to that inequality. Now I'm going to graph y is less than or equal to negative 1/2 x minus 4. My y-intercept is at 0, negative 4, and my slope is again at negative 1/2. I'm hoping that you would recognize that after putting on my y-intercept coordinate, going to find some other points to graph, that these lines are parallel because they have the same slope. Taking a look at my symbol, it's less than or equal to, which means that will be a solid line to graph. I need to label this line, y is less than or equal to negative 1/2 x minus 4. Again, this line does not pass through the origin, so that will be a good test to see if we're going to shade below, down here to the left, or up to the right, which would be in between. I'm going to substitute in the 0 for the y, and then I have negative 1/2 times 0 minus 4. Is 0 less than or equal to negative 4? No. That means I'm not going to shade in here because that's where the origin is located. I'm going to shade out here. Notice that my shading did not overlap. Therefore, there are no points in common, and so there is no solution to this system. There is no common shading. None of the points will be solutions for both of the inequalities. To review, be sure to get y by itself. Decide if you're doing solid or dashed lines. By picking a test point, shade on one side of the line, and the solution to the system is where the two shaded areas meet. If they don't, then that system has no solution. Please be sure to complete the reflection.